Welcome to Cloud on Air, live webinars from Google Cloud. We're hosting these webinars every Tuesday. My name is Carolyn Ujic, and today I'll be talking to you about how to start ML projects. You can ask questions anytime on the platform, and we have Googlers on standby to answer them. Let's get started. So as I mentioned, this presentation today is around how to start machine learning projects. It's called From Hype to Value. Machine learning is a big buzzword these days, but how do you know if you're selecting the right project that will justify your investment? We'll tell you more about how to do that today. So our discussion for today is going to start around the ML journey, what it looks like. What is that typical path for companies like you? Then we'll talk about use case identification and qualification, which is an important step in making sure that you select a feasible machine learning project. We'll walk through a few case studies, and then at the end, we'll have more time for question and answer. So first, I want to start by debunking a bit of a myth about machine learning. I often hear this from customers. So you have some data that's your input, you feed it into a machine learning model that performs some magic, and then you get your answers or your output. That's not actually quite how it works. So when you think about machine learning, you can replace the word magic with math. So machine learning fundamentally is using math to make predictions. So let's talk a little bit more about exactly what machine learning is. The way I think about it is it's a way to maximize the data you already have. And you're probably already using it, or at least collecting a lot of data. So think about machine learning in these three steps. You have a large quantity of data, you apply a mathematical algorithm to that data, and then you get a forward-looking prediction that will help you make a decision. Now, I want you to keep in mind these three steps as you think about how to apply machine learning in your organization. Sometimes machine learning is not always the best solution, but when you're making repeated decisions and you have large quantity of data, then it can often be a really great way to get a competitive advantage. So within Google Cloud, we have a professional services organization that helps a lot of customers discover feasible, high-impact ML use cases for their companies. And we really think about this as involving these three important parts. First is we want to work closely with you and your domain experts. You know your business best, and we're basically here to guide you. And this presentation as well will hopefully guide you as you're thinking about how to start ML in your organization. The next step is feasible, not magic. So again, the fact that machine learning is magic, it's a bit of a myth. So we really want to help you qualify your machine learning use cases and look at if they're actually technically feasible for your organization based on the data that you have. The last part involves making sure that those use cases are high impact. So looking at things like what sort of revenue might be generated by this machine learning use case, or what sort of cost savings can we expect if we were to complete this machine learning project. So we think about the machine learning lifecycle as having these 10 steps, and it's an iterative process. Today, we're going to really focus on steps 1 and 2, but I'll walk you through the end-to-end life cycle so you have a sense of what comes after you've defined those ML use cases. So as I mentioned, today we're focusing on ML use case identification, and that's the best place to start for a machine learning project. You want to get very specific in terms of what you're predicting and what decisions you're going to make. So for example, if you're forecasting sales for your stores, you want to be sure about exactly what you're predicting. Are you predicting sales for each of your SKUs every week, or for the next 12 weeks, or for the next 52 weeks? So you need to get very specific in terms of what you want to predict. The next step involves data exploration. So during this step, your data analyst will perform exploratory data analysis to really understand your data. What do you have? Is it good quality? How can we link together your different data sets so that we can use them in the machine learning project? We'll also try to look at relationships between the data as well as any signals that might be missing and how we might be able to bring in some additional data sets so we can have those signals and capture them in our machine learning model. Step 3 is around selecting an algorithm. And this often involves research in the problem space that you're working in. So for example, with that sales forecasting idea, you would want to do some review of what are some other successful ML applications related to sales forecasting. What sort of models are people using? And there's a wealth of information out there that you can really pull from so that you'll know where to start. After that, you get into your data pipeline and feature engineering. During this step is when you really think about what are those inputs that are going into our machine learning model. So when you think about those inputs, you'll want to consider again, how can you link them together into a single record that will sort of feed into that ML model? You'll also want to think about what are the components of that data pipeline, and we call those features. So again, just think of those as the inputs to the ML model. But you can get creative around how you engineer those features. So for example, you might look at the previous week's sales for that sales forecasting use case. But maybe you'll also look at same-store sales from 1 year ago, or maybe sales in that geographic region 2 years ago. This is where you can also start to be creative with your external data sets as well. So things like weather. You could pull in the average temperature from the week before, or if there were any inclement weather conditions like a flood or a tornado that may impact sales as well. Following that, you code your ML model. So this is where your ML engineer will come in and actually create that machine learning model that will be making the predictions. And often this is a very iterative process, and that's why you see step 6 listed here. You actually go back and repeat. You may tweak your data pipeline and your features and then see how your model performs. And then you may try it again with some different features, or you may remove some of the features that you thought were important, but maybe they aren't really improving your ML model. So again, keep in mind that you're going to iterate over and over again on your ML model until you get some results that you think are meaningful to you and your business. And that's what follows, step 7. During this step, it's important for you to share those preliminary results with your business stakeholders so they can really see what you've learned. Oftentimes, we'll define specific ML hypotheses during an ML project. And this is a really exciting part of the project where you can share if you prove those hypotheses with your business stakeholders. So for example, maybe one of your hypotheses were around weather has an influence on our sales. So at this point, you probably have some data that you can show to prove or at least show some preliminary findings related to some of those hypotheses. Once you've gotten to a level of success that meets your business needs, you can start to plan for deployment. And this step often involves thinking about the end-to-end business process that's affected by this ML model. So before, we were just trying to get those predictions right, but now we need to think about system integrations. So is this going to be part of maybe a forecasting platform that you use today? Does this need to be integrated with some dashboards that your executives look at? So you'll need to come up with a plan and the requirements required for deployment. After that, you actually operationalize your model into production, and Google has a lot of tools to help you do that. And then you want to monitor your model. So over time, your model actually needs to be retrained. You actually need to continue to teach it using new data, because we all know your business is going to continue to grow and change. So during the monitor phase, you'll want to come up with some specific metrics that you look at so you can determine when you want to do that retraining or when you want to maybe create a new ML model. So monitoring those metrics will be important to know when should you start that retraining process or when should you maybe start development on another ML model. So that's the end-to-end machine learning lifecycle. Again, today we're going to be focused on steps 1 and 2, but hopefully this gives you a taste of what the entire process looks like. So now you might be thinking, okay, this sounds great, but how do I do this? Who needs to be involved? Well, machine learning is really a team sport. It doesn't just involve that ML engineer that we talked about. There's actually a variety of players that you want to make sure are engaged. So these folks come from different areas of your business: engineering, analytics and science, and also domain experts. So I'm going to talk a little bit about some of the typical roles that we see involved in these machine learning projects. And I want you to think about who you might be able to bring into these roles in your organization. So the first is your project sponsor or decision maker. This is usually a leader that has some ownership of the process that's going to be impacted by ML, someone who can really come up with the success criteria for the project and can also decide when something might be ready to move into production. The next person is a domain expert. So this is usually someone who's doing the process today. And this is someone who's really involved in perhaps making a lot of human decisions around the ML problem. So for that sales forecasting example, it could be one of your planners or one of your financial analysts who's actually doing the forecasting today. And we'd want to engage with that person to understand how are they making their decisions and how can we try to get an ML model to think about the problem in that way. This is an interesting opportunity, too, to get ahead of some change management needs related to adoption of ML. So this domain expert is going to need to use this ML model down the road. And so engaging them from the beginning, really making the most of their institutional knowledge, will hopefully make it easier for them once you're actually deploying the model into production and you're asking them to use it. The third role that's important to consider is a data analyst. So we talked a lot about the importance of data. We're going to talk more about how you look at it as you're qualifying your ML use case. This person will be involved in assessing that data, performing that exploratory data analysis, trying to understand things like data quality. Another role that's important to include is the data engineer. And this person's really involved in creating that data pipeline. And again, the pipeline is what is ultimately going to feed into your machine learning model. A solution architect is also another important role for an ML project. That person is going to help you come up with your overarching solution for deploying your ML model. You know, I mentioned sometimes there are some technical integrations that are needed, and that solution architect would help define the requirements and help to understand those integrations so that you can have a successful deployment. And then the last role to keep in mind is a project manager. So there's obviously a lot of coordination involved across these different roles and throughout the ML lifecycle. And you need a project manager to help orchestrate all those different activities. Now, it's often great to think about someone who has some experience in more of an agile methodology, because as I mentioned before, there's a lot of iterations and repeating that occurs in an ML project. So you want someone who's got that experience and knows how to maintain that flexibility, even as they're trying to manage a more complex project. So I mentioned we're going to focus on steps for use case identification. Here's the way we think about it with our clients. So first, we want you to identify and prioritize your top business challenges. This will help to ensure that your ML projects have the greatest business impact. So oftentimes we'll get people together and it'll be a mix of stakeholders, and we'll have them come up with those top business challenges. Following that, once you've agreed on what those top business challenges are, we want you to brainstorm and get creative around ML use cases that address those top business challenges. So sometimes it's thinking about what decisions we need to make over and over again that could benefit from predictions. Getting people together and coming up with a large quantity of ML use cases is a great way to do this. And then we often have people vote collaboratively to decide where do we think we should start. And that voting helps us to come up with a short list of ML use cases that we really do some deeper qualification around. So normally we look at about 3 to 5 use cases that we'll hope to put on our ML roadmap. And step 3 involves qualifying those use cases. So we'll usually take a deeper look at the data, and we'll talk more about what we do there to assess technical feasibility. It's also a good practice to really quantify the business impact of the ML use cases. Again, so you can make sure that you're justifying your investment in the ML project. After that, you can create your ML roadmap for development. And we'll talk a little bit more about how to do that later on. So as you're starting to think about ML and where to begin, I want you to consider where you are on this path to ML. And this path is really the journey that any process or product might go through as it's maturing. So I'm going to walk through one example related to a contact center or support team, but you can think about any process or product in the same way. So if you have a new contact center, at first you may receive requests from customers and you may only have one person answering the phone. I know a lot of startups begin this way, but over time, as you get more and more requests from customers, you'll move out of that individual contributor phase and into the next step, which is around delegation. You might need a team of people to respond to those customer support requests. And that is phase 2 of delegation. During this phase, there'll be a lot of standardization that happens of your business processes so that anyone can actually perform that role. After that, we often see customers move into this digitization phase. So this will be where you'll maybe set up a ticketing system to automate and help digitize those support requests, the routing, the solution. And this is an important step because it really liberates and starts to collect a lot of the data that in the past you maybe weren't capturing in any sort of meaningful way. And over time, as you acquire more and more data, you move into this big data and analytics phase. And sometimes you might stay in this phase, and that's okay. But sometimes you may want to do something more sophisticated, again, especially where you're making repeated decisions. So you might want to move into this machine learning phase. So with this contact center example, you may move into a phase where you start automatically routing and predicting the types of issues that customers have based on their messages that they're sending you. So that's a very common use case we see a lot of companies implementing. But in order to get there, you really have to make sure you're in that big data and analytics phase, that you're collecting that large volume of data that really is required for any machine learning project. So again, consider where you are on this path to ML and how mature your business process or product might be. As you're thinking about ML projects, I also think it's good to be realistic about the effort that's required. It's a little bit different than your traditional software implementation projects. So think about these 4 activities that are involved: defining key performance indicators, collecting data, building infrastructure, and optimizing your ML algorithm. So a question for you: what % of time and effort do you think each of these steps take? So what we often hear from customers is that their expectation is very different than reality. So you can see here, a lot of people assume that optimizing the ML algorithm, that big green bar on top, is what really requires a lot of time and effort. But in practice, that's actually not true. You can see the reality at the bottom. The dark blue area of collecting data really takes quite a bit of time for ML projects. So you should expect that. The other area that often takes a lot of time with ML projects is building infrastructure. And that's represented by that yellow bar at the bottom. Now, Google Cloud actually has done a lot of the infrastructure building for you. So if you use some of our managed services like Cloud Machine Learning Engine, we'll actually take care of a lot of that effort for you. So keep in mind this ML effort allocation as you're thinking about your projects. And as you're doing your planning, you're really going to want to invest a lot of time in that data collection. And I think you'll be surprised how little time is actually spent on optimizing the specific ML algorithm. So as I mentioned before, data qualification is a really important step as you're thinking about the feasibility of your ML use cases. So this is a list of steps or a checklist that you can use as you're thinking about ML use cases and you're trying to assess their feasibility. As I'm walking through these, think about the data that you have to support your ML use cases and how it might measure up. So the very first step is around assessing the feasibility based on any data ownership or practical considerations. So again, machine learning projects require large amounts of data, and you want to make sure that you have ownership of that data so that you can use it to build your ML model. In many cases, that's not an issue. So for sales forecasting, for example, you probably own a lot of that data yourself if you're managing the stores where the sales are being made. But sometimes there are other scenarios where you don't own the data, and that can sometimes be a blocker. So it's important to think about those practical considerations. The next step is around collecting samples. So once you've identified your ML use case, we want you to consider all of the data that you currently collect that might be used in an ML prediction. So for the sales forecasting example, you may have historical sales records from all of your stores, and you'll want to get a sample of that data as you're assessing the feasibility of that use case. You may also want to bring in other data sets, though, things like promotional data that have a really strong impact on the problem as well. So identify all those different data sets and then collect the samples. You can then hand over those samples to your data analyst who will take a look at things like data quality. When I say data quality, we're looking at things like, are there a lot of missing values? Is there a lot of constant values in the data set itself? That can really help us to understand if the data is good quality or not. You also want to ensure you have labeled data. And this may be a new concept for some of you, but it's very critical for machine learning projects. So when I say labeled data, you want to have historical examples of what you're trying to predict. So for example, with sales forecasting, you want those historical sales records. And if you're trying to predict sales volume, you need to understand what that sales volume has been in the past. That data is used to train the ML model to teach it. So if you don't have those labeled examples, you won't have a way to train your ML model. You also want to verify that your data sets are large enough for model building. So one of the reasons why machine learning is gaining so much steam these days is because it has a lot to do with all that big data that's being collected in many different industries. So you want to make sure, though, that you have a large enough volume to perform well in these machine learning projects. Generally, the more data you have, the better. But when we're looking at some of these deep learning algorithms, the more complex algorithms that are based on the way your brain works, we often look for data points that are maybe in the hundreds of thousands as a minimum to get started. So again, you want to take a closer look at the data you have and make sure that you have a large enough volume of data. And lastly, you want to check for class imbalance. What is class imbalance? Well, it just means you need to have enough positive and negative examples, or enough examples of different categories that relate to your machine learning problem. So for example, I worked with one customer that was trying to predict truck breakdowns, and we needed to have more examples of trucks that had actually broken down. In the initial data set, they were collecting a lot of data points, but they only had 32 examples of trucks that had broken down. And that's an example of that class imbalance. You want to make sure you have enough historical examples of those trucks that are functioning well and the ones that have broken down. So again, you can use this as a checklist to think about, how does your data measure up for your machine learning project? So on this next slide, this is an example of an output that you might have as you're going through this use case identification process. So on the left, you can see 4 use cases that were identified. So imagine we just had a great workshop with different stakeholders across the business and from our tech organization. And we came up with these 4 use cases as a way of solving our top business problem. So things like cross-sell, upsell, customer-centric store layouts, a recommendation engine for online ordering, and a chatbot to support online orders. So through our qualification process, we assess the business impact and technical feasibility of each use case. And on the right, you see a nice visual summary of that in this 2x2 matrix. So you can see here, some of these use cases have a much higher business impact, like cross-sell, upsell. That definitely would have a nice tie to increasing revenue, but it's not quite as feasible based on the data that we looked at and the data that we're collecting today. So for our ML project, we may want to actually begin with use case 3 or 4. These still have a pretty high business impact, and they're much more feasible. So a recommendation engine for online ordering or a chatbot to support online orders could be 2 places where we could start. Now I'm going to walk through a few case studies that show you how other businesses are applying machine learning. So Uniqlo is a Japanese retailer that operates close to 2,000 stores all around the world. And they wanted to find ways to make their customers' shopping experience easier and more enjoyable. They looked at some of their top business challenges, and those involved things like the changing retail environment. We all know that the way that we make purchases and we shop is really changing quite a bit. And they also wanted ways to bridge the offline and online shopping experience. Uniqlo not only has many stores around the world, but they also have a pretty awesome website where you can buy things online. But they didn't have a good way to link those things. So in terms of the business impact, they really saw some pretty impressive results. So they created a chatbot that was integrated with their mobile app. And this chatbot would provide answers to common customer questions. And these things ranged from, is this black sweater available in the store that's nearest me, to, what color skirts do you have available in this style? And they really saw a great improvement in engagement as a result from this chatbot. So of the users that had the app, 40% of them interacted with the chatbot on a weekly basis. 40%. So that's pretty impressive in terms of engagement numbers. So when you think about the chatbot, there's also some great tools that we have to accelerate development. And so there's a great product available called Dialogflow. This is available through Google that really can make building a chatbot faster and easier. So if this use case interests you, I would encourage you to take a look at that. This next case study is around sales forecasting. So we worked with a global consumer products company, and they were interested in improving their sales forecasts from their distributors to their retailers. And there were a few business challenges that were identified that they were hoping machine learning would help them with. So their existing process for forecasting was very manual and it was very clunky. So they were using a lot of random spreadsheets to generate forecasts. They were also collecting quite a bit of data across their organization, but they weren't really using it. So they knew that they could do better if they found ways to harness some of this data that they were collecting today. But they were really only using a few data sets around historical sales and things like important holidays and events and seasonality. So they also felt they were missing some really important signals that were relevant to the problem. So they had a hunch that weather, for example, was very important in terms of driving sales of some of their products. But today they didn't really incorporate that into their modeling. So we worked with them to create a custom ML model, and the model actually yielded a 15% improvement in forecast accuracy. And it was projected to save them about $2 million, so a pretty significant business impact. And this model was interesting for them because it incorporated quite a few non-traditional data points like weather, demographic information, and even Google Trends information. So machine learning is a great way for you to think about some of these external data sets that might be relevant to your business problem and really find ways to incorporate them. So this company, for example, had been doing a lot of statistical modeling, and they were doing some pretty sophisticated stuff, but they weren't able to incorporate some of these other data points. And with ML, they were able to do that. So I'll walk through the top 5 tips that I have for you before you start your ML project. So the first is around making sure your use cases have a high business impact. Again, we want to make sure you get the return on investment for your ML project, especially if you're just getting started in this area. So really quantify the revenue and cost savings associated with a specific ML project. Get your hands around your data to assess feasibility. We walk through that data checklist, and it's very important that you go through that for your ML projects. We also encourage you to get samples of data so you can really take a closer look at data quality and make sure that the use case is feasible based on all of that data that you're already collecting. Number 3 is around being clear about what decisions you'll make with ML. So remember back to the beginning, ML is all about making predictions that can help you make better business decisions. So think about what those decisions are. What does that process look like today? And then how can ML help make those business decisions easier or better or more accurate? Once you've done those things, you should be able to build a roadmap for ML, and we encourage you to start with quick wins. What we found is that over time, you'll adopt ML for one use case, and then you'll adopt it for maybe 2 or 3, and that you'll have an acceleration of using ML in your organization. That's actually what we've seen at Google over time. as we've done more and more ML within our products. But in order to get started and really generate some results, we encourage you to start with quick wins. Going through that process will help you to establish a team, establish a model, a way of working, and also improve the quality of your data for that use case, but even for another ML use case as well. And then finally, the last thing I leave you with is remember, it's math. It's not magic. So stay tuned for our live Q&A. We'll be back in about a minute. All right, so we've got some great questions from our audience related to starting ML projects. So the first is, how is ML different than big data? So that's a great question. We talked a lot about how it's important to really be at that big data stage before you can move into an ML project. When you think about the difference between ML and big data, remember, ML is about making those forward-looking predictions. With big data, you're really looking at historical information, and you're performing analysis based on those historical trends. So big data, I like to think of and associate with like a live real-time dashboard where you're seeing exactly what has just happened. But again, machine learning is actually all about thinking of forward-looking predictions. So for example, big data could tell you what your sales were and trends in sales for the past month, but ML could tell you what do we believe the sales will be for next month. Okay, the next question, who needs to be involved in defining ML use cases? So this is another really important point that I want to make sure you understand. So ML use case definition is really a cross-functional collaboration. You need to bring in people from your business. You need to bring in your data experts. You want to bring in your technology leaders and your business sponsors. So you really want to make sure you have that diverse team. There's also that brainstorming step that's involved with defining the ML use cases. And what we find is when you have a more diverse team, you'll often come up with many more ideas and better ideas at the end of that brainstorming session. So remember, you want to have that very diverse team of folks across your organization. And we encourage you to think about business and technology and also different levels. So everyone from maybe your senior leaders, your directors, all the way down to that data analyst who knows the data really well and maybe is really excited about machine learning. How much data do you need for an ML project? So this is another good question. We talked a lot about how ML is really powered by large quantities of data. And in general, when we're thinking about a deep learning algorithm, a good rule of thumb is to think about having hundreds of thousands of data points as a starting point. Now, there are some nuances to that you may need to consider for specific ML problems. And that's where an ML engineer can help as you're thinking about those things. But again, we think that large quantity of data is important. What we also find is the more data you have, the better your ML model will perform. So again, if you have some pretty high bars for your performance of your ML model, you really do want to collect a lot of data, as much data as possible. That will really improve that model's performance. Okay, and the next question, how do you assess the business impact of an ML use case? Okay, so for this one, we talked a little bit about two important ways of looking at the ML use case. You want to look at the impact on revenue. So is there a way that this ML use case might substantially increase revenue? Or is there a way that it will save costs that you might have today? So I would think about those two things. But in your organization, you may have some standard ways that you approach creating a business case, standard ways that you approach creating a business case. And ML is not any different than other business cases that you may have put together in the past. So you can also use any sort of process or criteria that you may have in your company today when you're building business cases around other projects or other investments. So keep that in mind as you're thinking about the business impact of those ML use cases. All right, and then the last question we have here is, what are some other examples of using machine learning in retail? Okay, this is a really good one too. I think retail is a space where there's a lot of ways that ML can really make a big impact. So a few big kind of high-level categories to think about are things like merchandising, supply chain, pricing, customer experience, as well as digital insights. So when I think about those 5 different areas, when we think about things like merchandising, how does ML play a role there? Well, you can look at things like predicting trends, right, that may affect the stock that you want to have in your stores. Supply chain is another great area where ML can make a big impact. So you can think about different places in your supply chain where you might want to make predictions that can optimize it. So everything from, how do we want to set our production sizes, to what is our minimum inventory level in the store, to how can we keep our shelves from stocking out of items that are in high demand. I also mentioned the customer experience. So there are a lot of ways that ML can help there. So you saw the one example of a chatbot from Uniqlo, but you can think of other ways that ML can improve the customer experience. So things like a recommendation engine. This is a really great quick win for a lot of retail organizations. So looking maybe at your website and looking at ways that you can recommend products to customers based on the data that you may have collected about their shopping behavior in the past. So the last area I mentioned was around the digital experience and digital insights. And again, for those online storefronts that you might have, you're probably collecting a lot of data, and you can think about different ways you can optimize that experience for your customer as they're shopping and trying to make those purchasing decisions. All right, so I think that wraps up all of our questions for today. So stay tuned for the next session, Accelerate Cloud Adoption, using API management as an abstraction layer.